So last time we were together, we talked about taking square roots of both sides of an equation to solve any quadratic equation. So for example, in this first one, when we see x minus 1 squared equal 8, I'm going to take the square root of both sides to solve that. What is the key that I want to take the square root of both sides to solve this? One side is squared. So if one side is squared and it's all by itself, you make that problem a whole lot easier if you take the square root of both sides, and don't forget that there is a plus or minus, okay? So this tells me that x minus 1 equal plus or minus the square root of 8. So x equal 1 plus or minus the square root of 8. You will not leave that 8 just like it is. You're going to rewrite it as 2 times 4. So this is final answer, x equal 1 plus or minus 2, square root of 2. That is as far reduced as that one can go, okay? If you see x squared equal minus 25, I've got something squared all by itself. I solved that problem by taking the square root of both sides. Plus or minus, what's the answer? Yeah, plus or minus 5i is the answer for that one, okay? Now, what we're doing is we're marching through different ways to solve quadratic equations. Taking the square root of both sides is perfectly fine when one side is squared. That's not always going to be the case. So if you look at the next example, x squared plus 3x is equal to 0, okay? There is something squared, okay? So I could write it like this, x squared equal negative 3x. I can take the square root of both sides, but I run into a problem. What is that? On the left, that simplifies, right? What about on the right? The square root of negative 3x. Does that help me solve? I'm trying to isolate and solve for x. That makes it harder to get x by itself. So this is not a valid way, or, I mean, it's a valid operation, but it's not a good path to go down to simplify this equation, okay? So now what we need to do is talk about ways that we factor equations. So this is something you've covered a little bit in the past, but we want to make sure we hit several methods. Factoring is one of those skills you're going to need to keep sharp. We'll be using it this semester and next semester. So if I look at x squared plus 3x equals 0. Factoring says, factor means can I write something as two things multiplied? Like the factors of 35 are what? 5 and 7. So I can write 35 as 5 times 7. So can I factor x squared plus 3x? Is there something that these two terms have in common? They have an x in common, okay? What do I multiply x by so that I get x squared? X. What do I multiply x by so that I get 3x? That's 3, okay? Now this is completely factored. I've got two things that multiply and give me what? Two things that are multiplied and give me 0. What do you know about two things multiplying to give you 0? Yeah, one of those things has to be 0. There's no other way around it. So once I can get it in factored form set equal to 0, I know that x equals 0 or x equal negative 3. Those are the two solutions here. So it was easier to solve this equation by factoring than it is by taking the square roots of both sides. So what we need to do today, we need to talk about the different factoring methods that we have. Like I said, you should have seen some of these, but some of these we just may need to maybe a little bit more rusty than the other. What I just did here was the greatest common factor. So let's do a few more examples of that. When you're trying to solve something with the greatest common factor, you look and see what the two terms have in common. Okay, now in this one, are these equations? No, because they don't have an equal sign. So I can't tell you to solve this, but I can tell you to factor it. When it's set equal to 0, you're going to factor it, and then you're going to solve it. So what do these two things have in common? 3. So this is 3 times what? X plus 100. That's factoring out the greatest common factor there. What do the next ones have in common? Yeah, negative 7v. Okay. And so then what do I multiply negative 7b by so that I get negative 7v? 1. What do I multiply negative 7v by so that I get negative 77v squared? Yeah, plus 11v. Okay. What do the next two have in common? 2x. What do I multiply 2x by so that I get 4x squared? 2x. What do I multiply 2x by so that I get negative 2x? That's a negative 1. Okay. So I look and see what terms they have in common, and then I just sort of backtrack to see, okay, how does this has to multiply to give me this. You can check your answer by knowing that this is what? That is 4x squared minus 2x when I multiply it back out. What do the next two have in common? Okay, they do have a 7y. Let's try that. 7y. What do I multiply 7y by to get 14y squared? 2y. Okay. What do I multiply 7y to get negative 21y? Negative 3. And let me think. And that is it. Okay, 7y times 2y minus 3. Okay, you guys are good with this, right? That's easy. Okay. Let's move on to another factor method. It's called factor by grouping. This is the only method we have when you see four things together and it factors, okay? Factor by grouping is just a way of saying, let's use that greatest common factor, but let's use it 2 different times, okay? So let's look at this problem like this, okay? What I want to do, I want to factor out what do the first two things have in common. So looking at these first two, what do they have in common? Z. So if I factor out a Z, well, there's XZ and YZ, okay? Okay, so what do you multiply Z by so that you get XZ? X. What do you multiply Z by so that you get YZ? Plus Y, okay? Now let's move on to the next term. What do the next two things have in common? 5. What do you multiply 5 by to get 5x? X. What do you multiply 5 by to get 5y? Y. Okay. So I've got Z times X plus Y plus 5 times X plus Y. Now this is where sometimes people struggle. What if I had this? What if you had ZQ plus 5Q? What would you factor out of that? Q, okay. Look at this. What can I factor out of this? X plus Y. These two things share an X plus Y. So this can be written as X plus Y. What do you multiply X plus Y so that you get X plus Y times Z? Z. What do you multiply X plus Y so that you get 5 times X plus Y? There I am, okay? So that is the factorization. What you can do when you get to this step, you can just look and say it's whatever you have in common here, and then whatever you have left, Z plus 5, which is what you see there. Okay, you've seen this one before, or this one's a little bit trickier? You've seen it, right? Okay, let's do a few more of these. Factor by grouping, the only method I have for when I see these four things. What do the first two things have in common? X squared. So this is X squared, what, 5X plus 4, plus, what do the next two things have in common? 2, 5X plus 4. So what is this final factorization? Yeah, so 5X plus 4 times X squared plus 2. Looking at the next one, what do the first two terms have? Well, it's a different problem. What do the first two terms have in common? The first two have what, an X squared? So that leaves me 4X plus 1. Plus, what do the next two things have in common? What, 5? That's 4X plus 1. So this final answer is x squared plus 5, 4x plus 1, okay? So that's factor by grouping, okay? The only method we have when we have 4 things put together, you basically break it down into 2 problems where you're looking at the greatest common factor of the first two terms, greatest common factor of the second 2 terms, okay? Now the next one is, how do we factor something that looks like this? X plus P, X plus Q. How do we factor something? Excuse me, I want to factor. Let me back up. Sorry. I want to factor x squared plus bx plus c. I'm looking for 2 numbers p and q, so I can write this as x plus p, x plus q. Okay, so I'm looking for some kind of way to factor this. What happens when you multiply x plus p and x plus q? What does this equal? X squared plus qx plus px plus what? pq. Another way of writing this is x squared plus p plus q, x plus pq. Okay, so if I'm looking to factor something that starts out like this, okay, and I want it to look like this, okay, so if I want that to happen, I'm looking for these numbers p and q, and what must these numbers p and q? They must multiply. P and q must multiply to give me whatever this number is. Okay, if I'm looking for the solution to this, x squared plus bx plus c can be factored, x plus p, x plus q. When I multiply p and q, I better get c, okay? When I add p and q, I better get what? B, okay? So the whole purpose of when you see a trinomial that looks like this, I'm looking for 2 numbers that multiply to give me c and add to give me b. Now the way I typically do it, I don't know, there are many different ways people are taught this. I always just write this out. I'm looking for, in this case, 2 numbers that multiply to give me what? Negative 42, and add to give me negative 1. Okay, 2 numbers that multiply to give you this number and add to give you the number in front of x. Okay, now some of these are pretty easy and they just jump out to you. Factors, if it doesn't, the factors of 42 are, what is this, 6 and 7, or 3 and, what is it, 14, and then they start to repeat. Is there any way I can combine those numbers and get a negative 1? Which one? Yeah, so if I had a 6 and a 7, if which one was negative? Yeah. If I did that, those 2 numbers multiply to give me negative 42, and they add to give me negative 1. Okay? So that tells me this can be written as x minus 7, x plus 6 equals 0. And to double check it, when you multiply these, you get x squared minus x minus 42. So what does x have to be to make this a true statement? What numbers make this true? Come on, guys. You got 2 numbers multiplied to give you 0. One of these numbers has to be 0. Come on, you're going to have to wake up, guys. So x minus 7 equals 0. How hard is it to solve that? X equals 7. Okay. X plus 6 equals 0. Again, how do you solve that? -6. Okay. Those are my 2 solutions. X equals 7. X equals negative 6. This is where I factored it. This is where I solved it. Okay. Factoring is the method you use to solve the equation. Okay. So in all of these, it's going to break down to, can you find 2 numbers that multiply to give you the constant and add to give you that inside term? So let's do a few more examples of that. Let's look at this one. Now this one's a little bit different. So what you want to do with factoring is sometimes you have to use multiple methods. Okay, we've talked about greatest common factor, grouping, and we factor trinomials. Is there anything that these have in common? Any number? 2. I can factor out a 2. So this is x squared plus 3x minus 28 equals 0. Okay. Now, if I look inside the parentheses to factor that, I need to find two numbers that multiply to give me a what? Negative 28, and add to give me a 3. Okay. What numbers can do that for you? 7 and 4. Those multiply to 28. How do I get those to give me a 3 back? Yeah. So 7 and a negative 4. Those numbers multiply to negative 28, add to 3. So that tells me this is 2x plus 7, x minus 4 equals 0. There, we'll see how I got that. Spencer? Question? The 3. I need two numbers that multiply to give me negative 28 and add to give me 3. Okay? 7 and a 4 will do that. Okay? Now, so if I were to multiply this back out, I would get x, this is x squared plus 7x minus 4x minus 28. That's x squared plus 3x minus 28. That was the original that I started with. So now I set each factor equal to 0. When is 2 equal to 0? When is 2 equal to 0? Come on, guys. When is 2 equal to 0? Never is the answer for that one. When is x plus 7 equal to 0? When x equal negative 7. When is x minus 4 equal to 0? When x is 4. That's my solution to this one, okay? Pardon me? Yeah, it's this is your factor, this is your solution, okay? You notice that the sign changes, okay? So let's look at the next one. In order to solve this, I need two numbers that do what? Negative 24, add to 5. Now 24 is going to come up a lot. If you'll get to where you'll start to see patterns here, but if you don't, 24 is 1 times 24. It's 2 times 12. It's 3 times 8. It's 4 times 6. And then it's 6 times 4. Those numbers start repeating. Is there a way those numbers can combine and give you a 5? Yeah, 8 and negative 3. So an 8 and a negative 3 will multiply to give me negative 24 and add to give me 5. What do I do with these two numbers? Yeah, I just go over here and say this is x plus 8. X minus 3 equals 0. Therefore, x is equal to, 3 or negative 8. Those are the solutions for that. Mm-hmm. No, because this you have to this is the factorization. These numbers tell you how to factor, and then you set each factor equal to 0 to get the solution, okay? So in this case, this step, this was how you factored that original, and then when you get to this step, this is how you solve, okay? So you'll need to write it in factored form and then solve it. Now, it gets a little bit different, guys. So what we were solving there, we were solving x squared plus bx plus c equals 0. It gets a little bit different when I've got ax squared plus bx plus c. What's the difference between x squared plus bx plus c and ax squared plus bx plus c? The a, okay? So everything I've been doing so far, the number in front of the x squared was what? 1. Now, how do I do it when the number in front of x squared is not a 1? So it changes just a little bit. Here, I need two numbers that multiply. They need to multiply to give me a times c, and they need to add to give me B. Okay, so in this case, in this problem right here, what is A? 6. B is 11. C is 4. Okay, so I need two numbers that multiply to give me 6 times 4, which is 24. Okay, those numbers need to add to give me what? An 11. So that was the difference here, is like I'm not finding numbers that multiply to 4, I'm finding numbers that multiply to give me 6 times 4. Okay, so what numbers can multiply to 24 and add to 11? Yeah, 8 and 3. And now here's a key difference that you have to do. In this one, what you have to do now is I have to rewrite this problem as 6x squared plus 8x plus 3x plus 4 equals 0. Now, what's the difference between these two equations? Are they the same? 6x squared, this is 11x, that's 11x. So I haven't really changed anything, okay? But I've got it in 4 terms. What's the only factoring method you know for something that has 4 terms? Grouping. So now I can factor this by grouping. What do those first 2 terms have in common? It looks like a 2x, and I'm left with what? 3x plus 4 plus 3x plus 4 equals 0. Okay. Now, if it helps you, you can think of this as there's a 1 in front of that parentheses, okay? So what's the next step? How does this factor? Yeah, 3x plus 4 times 2x plus 1 equals 0. 2 things are multiplied to give me 0. I have to set each of these equal to 0. So if 3x plus 4 is equal to 0, then 3x equal negative 4, x is equal to what? Negative 4/3. If 2x plus 1 is equal to 0, then 2x equal negative 1, x equal negative 1/2. Okay, a little bit more involved, but you guys can handle it. It's putting two factoring methods together. Let's look at the next one here. So if I'm going to solve this, I need 2 numbers that multiply to give me what? Yeah, what is 4 times negative 15? Negative 60. And they have to add to give me 17. Okay. So factors of 60. It's 1 and 60. What is it? 2 and 30. 3 and 20. It's 4 and 15. 5 and 12. And what? 6 and 10. Is there a way I can combine those numbers and get a 17? Which one? Huh? Yeah, so there are 2 ways. So let's think about it. Okay, guys, let's think about it. I have to multiply to get negative 60. So one of these numbers has to be negative, one has to be positive. Here, I could get to 17 if they were both positive or both negative. So the only one that's going to work here is a 20 and a 3. And then which one has to be negative so that I get a positive 17? Yeah, that one has to be negative. So positive 7. Oh, you're right. I copied that down wrong. It's a negative 17. So that means that the 20 has to be negative. Like that, okay? Thanks for catching that. So now I use these numbers to rewrite this problem as 4x squared minus 20x plus 3x minus 15 equals 0. Then I can factor this thing by grouping. Now you may ask, I wrote negative 20x and plus 3x. What if you wrote plus 3x and minus 20x? Pardon me? You're going to get the same place. You'll get the same answer. It doesn't matter that I wrote negative 20 and positive 3. You could have written positive 3 and negative 20. Okay. What do these first two terms have in common? Yeah, 4x, and that leaves me what, x minus 5. The important thing is, whatever this sign is, this next sign that you see, you have to copy that sign down exactly. It's a plus sign. And what do these have in common? 3. X minus 5 equals 0. So this tells me that 4x plus 3 times x minus 5 equals 0. So this tells me that x is equal to 5, or what? Negative 3/4. Okay. Now this is the graph of a what? This right here. This is a what? When we graph it, it's a parabola, okay? These are going to represent, this is when you set it equal to 0. When you set it equal to 0, you're finding the what for this parabola? The x. These are the x-intercepts when y is equal to 0. So it tells me that right now this looks like the form, you know, what is it? A, x minus p, x minus q. So the x-intercepts are going to be at what? 5 and negative 3/4. So if I were to try to graph this guy, so somewhere here at 5 right here and at negative 3/4, I'm going to have x-intercepts, okay? Where's the y-intercept for this parabola? Y-intercept is where? Negative 15. So negative 15 is the y-intercept, okay, which is right here, okay? This parabola opens where? Up or down? It's going to open up. How do I find the axis of symmetry? It's going to be what? 17 over 2 times 4, 17 over 8, which is 2 and 1/8. So somewhere over here is an axis of symmetry. And then I would need to find a vertex. So I would need to plug that in. So 17/8, I could plug 17/8 in here. I could find a vertex for this guy. Okay. So what we're done when we solve it, when we set it equal to 0, we're finding the x-intercepts. Okay. So what comes into play here is you could be asked to graph one. Factoring is a way to solve it and find its x-intercepts. Okay, let's do one more or two more here before we end up. What time does class end? At 50? Okay, this one. Solve by factoring. Everyone that I've solved so far was set equal to what? 0. Yeah. We love to solve things equal to 0, so just rewrite it. If I were to factor it and it was multiplied to give me 2, I can't set each factor equal to 2. That's what's special about 0. When you multiply things to get 0, one of them is 0. Now, when I go to factor this, first thing I want to say, I can make it easier if I factor out a greatest common factor. What do these all have in common? What number? 2. These are all even numbers. So 3x squared plus 13x plus 4 equals 0. Now I'm looking for two numbers that multiply to give me what? 12. And they add to give me 13. If I had not factored this 2 out, I would be looking for numbers that multiply to 48 and add to 13. Still possible, just the numbers are bigger, okay? What numbers multiply to 12 and add to 13? Yeah, 1 and 12. So I can write this as 2 times 3x squared plus x plus 12x plus 4 equals 0. And then I factor by grouping. So these first two terms have an x in common. 3x plus 1 plus the next factors have a 4 in common. So this tells me 2, x plus 4, 3x plus 1 equals 0. So x is equal to -4 or -1/3 when you set each of those factors equal to 0. Okay. Let's do the last one here. Now the last one, they all have something in common, which is a what? A 3. But I'm just going to work it like, suppose you didn't catch that. It's still going to work out. Suppose I did not factor out the 3. What happens when you multiply? I need two numbers that multiply to give me a what? -27 and add to give me a -6. Okay. So factors of 27 are 1 and 27, 3 and 9, and that is it. Okay. So is there a way to combine these to get a -6? Yeah. So 3 and -9. So I rewrite this as 3x squared plus 3x minus 9x minus 9 equals 0. Now you got to pay real close attention to the minus signs here. That's what trips people up in this one. What do these first two terms have in common? 3x. That leaves me with an x plus 1. Now, whatever this next sign is that you see right here, you have to copy that sign down just like it is. It's a minus sign. Okay, now I look at the 9x and the 9. What do they have in common? A 9. So what do you multiply -9 by to get -9x? No, x. Okay. What do you multiply -9 by to get -9? Plus 1. Okay. So this minus sign, when you're factoring out a minus, you got to take extra caution. So -9 times x is -9x. -9 times 1 is -9. Now, if you get two different things here in parentheses, like if you got x plus 1 and x minus 1, you got to go back and check it. These have to match exactly. So what is this factorization? What, 3x minus 9 times x plus 1 equals 0. Set each of these equal to 0. And you get what, 3x equal 9 or x equal 3. And here you get x equal -1. And if I were to factor this guy, what are the x-intercepts? 3 and -1. So if I were to try to graph this guy, 3 and -1. Where do you think the axis of symmetry is going to be on this guy? Yeah, it's going to be right here. Okay. Where do you think the y-intercept is on this guy? -9. So the -9 is the y-intercept, which is right here. And then to find the vertex, I could plug in a 1. If I plug in a 1 here, this is what, 3 minus 6 minus 9. So that's -3 it's -12. So it's a little bit off of my grid here. So if I were graphing the parabola, somewhere down here at -12 would be the vertex. So this guy would look something like this. So that is 3x squared minus 6x minus 9. Okay? So what we're doing by setting something equal to 0, we're solving it or finding the x-intercepts. Okay? So we covered quite a bit of ground today, guys, in factoring. So take a look at this. What I'm going to do, since today is an X day and you have all your classes, and then tomorrow is a block day, what I'll do, I'll just check homework when I see you on Thursday. Is that right? No. Yeah. When I see you on Thursday, I will check homework for 6.2 and 6.3. Okay. So tonight's homework is 6.2. Tomorrow's homework is 6.3. Since it's a weird schedule, I'll check both of those on Thursday. If you have them ready before then, that would be fine as well. Okay.